All right, line H1, we're going to take a look at learning task number 1, which is going to be describing the features of single-phase 3-wire distribution systems. Now, in level 1, you would have gone through standalone residential services, where we've got a service, usually up to no more than 200 amps, that is going to be sending power into a standalone residence. What we're going to be dealing with in second year over here is we're going to start introducing the concept of row housing. Duplexes, triplexes, quadplexes, any of these where they're going to be individual dwelling units, all accessible from ground level, that are going to be sharing common walls and a common roof. If you go through a lot of our newer subdivisions, we see those. They're not apartments. Apartments are going to be stacked on top of each other. These are ones where they are going to share adjoining walls and all be accessible off of ground floor. In a lot of cases, these services are going to be single phase. There's no need for three-phase. We don't have a lot of three-phase types of loads. We don't need that type of distribution. So we will go and stick with our single-phase 3-wire distribution, but it'll be a little bit different because we're going to come in as a main distribution and then drop down into what we refer to as a sub-distribution. Let's start by taking a look at a simplified one over here. Now, this is going to be one where we've got a main switch that is going to be, 400, 600, maybe even 800 amps, although those are fairly hard to come by. We'll start by examining that over here on this end. So that whole section is going to be my main overcurrent device. Ahead of my main overcurrent device, I'm going to go and have a couple of conductors, these ones over here. These are going to go and be called the Consumer's Service Conductor. I'm just going to short form that as CSC. Consumer Service Conductors, because these are owned by the consumer and they are put in place by you as the electrical contractor. Over here, we're going to go and make a connection, and from here, the conductors that are going to be coming in are going to be known as my supply service that I'm going to go and have. Now, the supply service could be coming overhead, as we have in this case. Supply service. Or it could be coming underground, if we're coming in through a L-shaped pull box and stuff into this as well. It doesn't matter which way we're coming in. That's anything that is going to be past the point of connection is going to be supply service. Anything that is going to be downstream of the point of connection is going to be the consumer service. And it stays the consumer service all the way up to this point over here, where we go through our first PNC, protection and control devices. Over here, we see the control device is going to be a 2-pole switch. It's going to be a common handle switch over here. So these ones will be interlocked to that handle, followed by a set of fuses that we have over here inside of fuse holders. At that point, past there, we are going to go and become a feeder. That's going to be from here all the way through into this section is all going to be feeders. Because they are feeding to other pieces of equipment that is going to go and feed out to individual components. This is technically coming from this portion over here. We'll talk about that later on, but over to this panel would also technically be called a feeder, but in a lot of cases we end up calling these things sub-feeds because it's not the main set of feeders. It's going to be a smaller set. So we'll call that one a sub-feeder over here. And then anything that is going to be coming out of that panel is going to be the individual, what we refer to as branch circuits. So, going back through once again, supply service is going to be owned by BC Hydro up to the point of connection, underground or overhead. Consumer service is going to be anything that we place in that goes from either our weatherhead or from our pull box down into the switch, and the consumer service stops once we hit our first protection and control device. From our protection and control device, then we are going to go and have feeders that are going to go to my main pieces of equipment. And then I'm going to go and have sub-feeders to, smaller pieces of equipment. And then ultimately I end up on branch circuits that go to the individual devices itself. Looking at our service that we have over here, and let's get past that little section that's labeled as being 6102, 104, and 6400. We're going to come back to that one. We're just going to go through what this service looks like, and then we'll come back to a bunch of the rules themselves. So we see we're bringing power in. That's easy enough for us to understand. We see that we are bringing in 2 lines. We're also bringing in this one over here. This one we refer to as the neutral. In the code book, it does have another name in a lot of places. They're going to go and call this thing the GCC, the grounded circuit conductor. Because it does carry current, right? When we take a look at it, we know that we're going to have current coming in on these ones, going through whatever we have out there, and then coming back up on this one to the transformer. It's designed to be a circuit conductor, and we call it the grounded circuit conductor because we are going to go and ground that thing, right? Where we have our main neutral coming in, we're going to see the main neutral. It's going to be on a pad like what we have over here. That pad is going to go and have a bonding strap down to the main can itself, and we're going to go and take our actual ground conductor. That's going to be this one. The ground conductor itself is going to come in, and it is going to tie into that neutral pad. And at that point, we have grounded our neutral down. Past there, we don't have any grounding that we are going to have. We're going to have bonding for sure, but we are not going to go and attach anything else to the actual ground via grounding electrode. All of our neutrals need to float. All of our panels, wherever those things are going to be, need to go and have their bond screws removed because we've already tied that in back over here. Coming out of our main switch, we're then going to move into this section over here. This is going to be referred to as the CT cabinet, sometimes referred to as the metering cabinet. Now, if this is going to be a 120, 240, 600 amp service, we would not need to have PTs or voltage transformers to drop us down to a level that we can go and meter. But we would need to go and have our CTs. We covered this inside a transformer. Instrument transformers are going to bring us down to 5 amps, and they're going to bring us down to 120 volts. But in this case, because it's a 12240, we're already at 120 volts, so we don't need that 120 volt one. We'll scratch that. We will just have the 5 amp. This is going to be my bus type of CT that is going to be mounted inside of here. So I'm going to take my service conductors in, and you see that I'm interrupting the black line and the red line, right? All of the current is coming in on that. I don't need to go and have the neutral itself through. Neutral passes through without connection. Sometimes you'll see them where there will be a neutral lug on the inside of these cabinets, but usually this is not going to be required for a single phase service. Once again, check what hydro specs to you before you start a job and work off of that. There does also have to be a chunk of space that's going to be left inside of here. One of the big errors that most electricians make on their first service that they build that has one of these is they're going to go mount that CT right in the middle of the box because you get this big old box and you get the CTs, you get big conductors, and they go perfect. I will shove that thing right here into the very center of it. That is always going to be a mistake because there's going to be, think about roughly like a shoebox size device that has to go into there. It's going to be called the test block. We're going to cover over what that is later on, but the test block is going to be where they're going to go and take connections from all of the CTs, all of the voltage, stuff like that. They're going to put them into a switching device, and that switching device then feeds up to the meter. There is going to go and be a 100 amp meter base that needs to be placed inside of here. They're going to actually feed it with like number 10 gauge wires. They don't need much because they're only working with a maximum of 5 amps, but they need to have a place where they can mount that meter in, a standard meter socket, and that they can seal, etc. So that's going to be mounted over top of there with a short chunk of pipe. There is specs. There's what's referred to as the BC Hydro Metering Guide. It's free. It's online. It's a PDF. You can download it, and then you can go and use that to go and lay out how far these things need to be, distances to center on these. All of that is laid out because they wanted these things to be accessible. All right, coming out of our CT cabinet, we're then going to go and feed into this section over here. And this section over here is going to go and have these long conductors over here, bare aluminum conductors or bare, copper conductors that are going to be mounted on little insulating blocks. We refer to those as bus bars. And those bus bars are going to go across the bottom of this cabinet over here. It's a bus bar cabinet. And from that bus bar cabinet, we are then going to go and feed up. Now, this cabinet over here could be contiguous, part of this, what we refer to as its own meter stack, or it could be just a separate bus bar and we mount these meter stacks over top and we just terminate into it. What's happening inside here is that we have got a meter stack that is going to be running conductors up, a red conductor, a black conductor, and a white conductor, so 2 lines and a neutral. We're going to run those up inside of here, and each of these is going to go and feed into a breaker. Okay, well, I'm just going to draw them in over here like that. And that breaker is then going to go and feed into a meter base. So that one through like that. And then that meter base out of there, we are then going to go and feed to our actual conductors. And they're going to go up this section over here, which is going to be a chase weight like that. Take this one, we'll do the same thing. Meter base, put that one up there, and then obviously you would have your neutral that would have come into there as well. That's going to be spliced on and carried through as well. So inside of here, we're going to have wiring space that's going to be off to the side. That's all these removable covers here. And then we're going to have the individual units themselves. All this red and black and white, the main conductors that come up here, are going to be buses that go and transfer to all of them. But every single unit is going to have its own main breaker inside of here that we can shut off. And that's going to go and shut off power to the meter. But we see that all power that goes out to the actual unit, you know, inside of the units that you're going to have inside of your duplex or triplex, quadplex, whatever it's going to be, are all going to be metered inside of there. So everybody that is in there is going to go and, you know, get their own meter. Now, they all get read in one central location, our metering closet, so that you don't have to have, you know, the hydrometer readers coming into everybody's individual unit. It also allows us, as, you know, electricians, if we need to work on something, we can kill power up here so that we can work on, you know, the feeder itself, the mains of this panel, anything like that. Yeah, you could kill the main breaker inside of the panel, work on the actual panel itself, but if you needed to work on the incoming side of that single-phase unit panel, you would have to do that upstream. So it's a very common way that we go through these, you know, with the meter stacks. It does also allow for, you know, this to be in a centralized location that's only going to be accessible to authorized personnel. Individual holders of their, like whoever owns, you know, this suite or the next, they're not going to go and have access into this because otherwise, you know, somebody gets in a war with their neighbor and they go there, they flip their main breaker or something like that, right? So this is going to be something that is only going to be available to, you know, whoever is in charge of your electrical system. Strata will hold keys for this. All the metering takes place inside of here. We'll have individual units that are going to be metered off of it. We're also going to go and deal with what we refer to as house loads or general compound loads. You know, things like roadway lighting that might be on there, courtesy parking spaces, electric vehicle chargers, things like that that can be not necessarily taken out of somebody's individual unit, but, you know, that everybody can benefit from. That's all going to be taken out of there, and that'll be placed onto a separate meter, and that's going to just get billed as the house, and that gets rolled into, you know, the strata fees, etc. Okay, we will have to go and have that space for the CT and the test block inside of here. Here's a zoomed-in picture of what the meter or what the CT cabinet itself actually looks like. If you take a look at the incoming side over here, we see we've got incoming power is going to feed through the CT. It's a bar type of CT. So the red line feeds right through to the other side. There's just going to be multiple windings of small wires around here and around here that are going to be tied together, and then they come out to those two over there. That's going to be your 5 amp CT output. Now a CT is going to go and have a low amount of current, which means it's going to have a high amount of voltage. There's always that danger with the CTs, and we've talked about this before, that anytime that you're going to remove a CT, you should be shorting out that meter first. The test block is going to go and allow for that. Now, this is my test block layout. I'm going to have one set of switches on my test block that I'm going to use for voltage. Over here, you can see that they're going to go and have 240 volts, right, from here to here. So they're going to be measuring both lines at the same time. That's going to get fed into their single-phase meter base, and that's going to go to the voltage section, right? That would make sense. They're going to be measuring the line voltage at all times. The other two lines over here are going to be going through and being fed into the amperage section, and then that meter together is going to go and multiply volts times amps together, and it's going to go and display that as watts. They also have the ability to measure in phase versus, you know, quadrature types of currents. They can tell when we have got a lagging power factor and, you know, how large that magnitude is and anything like that as well. Looking at these, the voltage switch, we see it's easy to go and kill that. If I wanted to pull this watt meter though, so put that all inside of that watt meter, we see that it's not going to interrupt the main load current itself, right? If I pull that watt meter out, I still am going to go and have power that can travel through here and out. Same with on, you know, the other line over here, through here and out as well. So pulling the meter on one of these single-phase CT metered services will not go and interrupt the power. It's a common misconception because on a regular, you know, 120, 240, 200 amp single phase installation, you can pull the meter and it's going to interrupt current, and that's going to be like an emergency type of thing. These ones, if there's an emergency, you do not pull the meter. You need to go and kill everything upstream, find that main switch on the system and kill that instead of trying to go and pull that meter. The test block itself on the current section is going to go and have a make before break type of switch. So before this switch comes off of here, this would be these two switches closed like that. Before the switch is able to come off of there, it is going to go and make contact with a little shorting bar that goes across like that, what's shown inside of the drawing, so that it will short out the CT. So when the hydro meter technicians are working on this, they can pull open each of these individual switches. This one's going to short that CT, so then they can go and safely work inside of that cabinet. Once again, these are going to be laid out by whoever's going to be supplying your power, in most cases BC Hydro here in the province. They're going to tell you the size of the CT cabinet that you need to go and acquire. They're also going to go and give you mounting dimensions. Make sure that you leave room, because this has been historically poorly laid out inside of their documentation. It's kind of under this assumption that you've gone through a proper apprenticeship and someone's explained this to you before, so you know not to place it in the center. Otherwise, if you place in the center, you're going to fail that inspection. Then you're going to come back and fix that. It's a separate inspection, not technical safety inspection. This is a BC Hydro inspection. They will go and say, no, we're rejecting that. We're not going to connect. You got to go and fix it up. Yeah, the CTs, we've talked about that. Don't ever pull them, and make sure that those terminals are shorted. It does not cause any issue. Let's just go back to the very beginning of this chapter over here, and there just was a couple of rules that we need to go over top of that deal with some commonly held misconceptions as well. 6102. 6102 talks about number of services of one characteristic to a building that we would be allowed. So normally, if I have got a building, I can have more than one service to it, but they are going to be different ones. I can have a 600-volt three-phase service to a build structure. I could also have a 120-240 single-phase to a building. It's not common that we're going to have more than one to a single building, but it does happen, and it is allowable. What 6102 prohibits us is that we are not allowed to go and have like two 120-240s onto a building, because then people start, grabbing stuff off the wrong neutrals, and there's cross wiring, and it just all turns into shambles. There are a few exceptions to it. When we have got some emergency equipment, there's this thing called a fire pump that is going to just run the sprinklers in the case of a fire. But outside of that, coming to a building, you can only have a single service per voltage level coming in. So you could have, a building feasibly that is a 120-240 single phase. It's also got a 122-8 three-phase to it. It's also got a 277-480 three-phase to it, and a 347-600. I don't know why you would ever want to do that. You'd be far better off, instead of dealing with all that paperwork and hydro, you'd be better off to do it all yourself through transformers inside there, but it would be allowable. 6104 talks about consumer services that are going to be the same voltage, where they're going to be allowed on a building to supply more than one unit. That's going to be no more than 4. And this is why, when you take a look at any of these quadplexes, why they're limited to 4. You'll see no more than 4 together, and then there's kind of a break, a little bit of green space, and then they'll have another 4 together, and then there'll be a little break. The reason that they have them like that, it's not just for, the electrical. There's also some fire protection. You don't want the whole thing to burn down in one row. You got some fire breaks in between. But this definitely plays into that, because otherwise it changes the whole electrical service for that installation. 6400 is going to deal with metering equipment. It's going to deal with CT metering inside of there. And if you go into those rules, it's going to talk about current loops that we need to go and have inside of them. And it's going to talk about when we have got our metering that is going to be downstream of our main switch. We go to this one over here, and what you should note about it, and there, hold on, undo. There we are. What you should note about it is that we now have got our main switch ahead of our metering. This is allowable. We expect this to go and happen. This is different than what we have on our residential services, because residential services, usually what happens is we come in, we go into a meter base. From that meter base, we then feed out into a panel. So we go metering, then PNC. PNC, metering. In this case, we are going to go with PNC, protection and control, then we are going to go to metering. It's just due to the size of the amperage that we have going into here. All right, that covers off learning test number 1. Learning test number 2, we're going to go and do a whole pile of calculations that are going to be utilized inside of these.